All right, we're here at 6.5, and today we're going to be looking at finding real roots of polynomial equations and trying to find all of those. And sometimes they turn out real nice, and graphing can be helpful as well as we do these, a good way to check and see. But we want to do some work on some factoring type of things too here. So let's take a look at a couple examples. Like if you're doing this by factoring, and you always want to take out whatever's in common between all three terms. And we can take a 4 and an x to the fourth out. And if we did that, we'd be left with x squared plus x minus 6. Well, that's a trinomial that can factor into two binomials. The two numbers that multiply to negative 6, but um, add to positive 1, they're going to be positive 3 and negative 2. So therefore, our zeros are going to be 0, negative 3, and 2. And if we graph that, we would see the same exact thing. Kind of crazy kooky, but true. All right. Now, when we solve this polynomial, it's good to get everything over to one side. And there isn't anything we can take out of all three terms. So now we factor. Now, if it was x squared, we would go x and x in the first spot. But since it's x to the fourth, we're going to go x squared and x squared. And two numbers that multiply to 25 but add to negative 26 are going to be negative 25 and negative 1. Now, those are special factors. Those are a difference of two squares. So we can factor that back down into x plus 5, x minus 5 and x minus 1 and x plus 1, giving us the four zeros of negative 5, 5, 1, and negative 1. So some neat ways of doing some factoring. Now, again, some of those can be kind of tricky. Don't be afraid to graph to get those others. Sometimes that's a good way to do it as well. All right, some other things we're going to talk about is the idea of what's called multiplicity. Sometimes when a root, it kind of goes up and hits, kind of like what we have here. It's going up along here and it hits and goes back down. We say that has a multiplicity of 2. It's a double root. You're going to see that when you factor. If you get two of the same, that's the phenomenon that's going to happen. All right. Now, if it just has 1 0, there isn't multiplicity. Basically, it's just going to kind of go through like that, and it's not going to bounce back or anything like that. Now, we can also have a multiplicity of 3, and that's where it bends. What happens here is that it's going up. It looks like it's going to bounce and come back down, but then it goes right back up. Is what happens. So there's going to be 3 zeros at that spot, 3 roots as we have that at 0. So that's the multiplicity that we have there as well. All right. Now, a couple other things as we're finding these, and graphing can be very helpful, but we're going to do a little method because what happens if they're imaginary down the road, we're going to have to be looking at that. The rational root theorem basically says if you have a polynomial, to find roots, you can always take any factor of the p term, which is the constant in the polynomial. You can divide that by any factor of the leading coefficient. All right. Now we also have the irrational root theorem that says basically they travel in pairs. If you get the square root of 2, you also get negative square root 2. You get those. Those are all the cases. Okay. All right. So how does this all work? If we were to find all the real roots of 2x to the third minus 9x squared plus 2 equals 0. Yeah, okay, here's the rational root theorem. What it's saying is that any of the factors of the constant term, so 2 or 1, could be positive or negative, if we divide that by any factor of the leading coefficient, 2 or 1. So basically, the ones that we could possibly have over here, you could 2 over 2 is 1, 1 over 1 is 1. You could have 2 over 1, which is 2. You could have 1 over 2. So these are the possibilities of the roots that we get there. So if you like to play the guessing game, you think, you can try this. What we're going to do is we're going to divide out one of those roots. So it's going to take it from a cubic, it's going to move it down to a quadratic is what it's going to do by dividing that root out. Well, if you go ahead and graph it, you can kind of see which one it is. We're going to try a half. And so if we take the coefficients and we synthetically divide that out, we have 2, negative 9, 0, because there's no x term, and 2. If we do that and we synthetically divide, we know that 1/2 is a factor because we have a remainder of 0. So by dividing that out, that leaves us with the quadratic 2x squared minus x minus 4. If you take a 2 out of that, here's what we're left with. Now that does not factor. So what you have to do there is you have to use the quadratic formula. So we're going to use the opposite of b, which is 4, plus or minus the square root of, well, b squared is 16, minus 4 times a times c all over 2a. All right, so what do we got there? So we're going to have 4 plus or minus. All right, this looks like, what do we get there? That would be 8. That would be the square root of 24 over 2. And let's see, this would be 4 plus or minus. That would be 2 root 6 over 2. And so if we divide all those by 2, it's just going to be 2 plus or minus root 6. And that's that irrational root theorem, guys. If you get an irrational root like 2 plus the square root of 6, you always get the negative version too. So here are all 3 of those real roots. Okay, and that's how you kind of do those. Those are kind of tricky. As we work on those, we'll have plenty of practice. Let's let you get into the assignment a little bit, and then what we'll do is we'll let you go through some questions at the Google Meet and do that. But let's try a few of those and see how it goes. Okay.